Morning. In this video, we're going to continue to talk to you about the Pythagorean theorem, how we can use that to find missing side lengths, and specifically we're going to focus on how we can solve real-world problems by using the Pythagorean theorem. There's a couple of vocab terms we want to get familiar with. When we talk about a cone, we're talking about this shape here, a 3D figure that has a circular base, and the whole figure comes up to a point at the top. The distance halfway across a circle is called a radius, and when we have a cone, we differentiate between the height, the difference from the middle of the circle to the top of the cone, from the slanted height, the difference from the top of the cone to the edge on the bottom of the cone. So, the first problem we're going to take a look at is asking us to find the perimeter for the triangle shown below that's colored green. We get two side lengths, 10 and 6. We don't know what side length G is, and we're asked to estimate our answer to the nearest tenth when we do find the perimeter. Pause the video and take some time to figure out pause the video, take some time to figure out what is the perimeter for the green triangle. Welcome back. Hopefully, the first thing you realized is that perimeter measures the distance all the way around a triangle, and to know the perimeter, we're going to have to know all three sides. Because we only know two of the three sides, it's a right triangle, we know we can use the Pythagorean theorem to help us find that missing side length by using one of these two formulas. Here, I'm going to go ahead and open this drawing because the first thing I want to do is identify which side is the long side, the hypotenuse, that's going to take the C. I look at the right angle, the side that's opposite the right angle, G is the biggest side length every time, and that tells me the two sides I know are A and B. So 10 and 6 are going to plug in for A and B. When this is the case, when I don't know what C is, I prefer to use this formula, A squared plus B squared equals C squared, because the C is already isolated on the right side of the equation. So we're going to use that equation, and the first step is to substitute. We're going to replace A with 6, because that's what A was equal to, and we're going to replace B with 10, because that's what B was equal to. The next step is to take this equation and evaluate the exponents. 6 squared means 6 times 6, or 36. And 10 squared, 10 times 10 gives us 100. The following step, we need to combine our like terms. 36 and 100 are constants on the same side of the equation, so when we add them up, they give us 136. That's equal to C squared. What's the inverse operation that's going to help us get from C squared down to C, so we know what our equation, we know what the missing side length is? We need to perform a square root on both sides of the equation, because the square root of C squared is C. It means we have to do a square root to the left expression as well. Square root of 136. The square root of 136, is that a perfect square? No. So I'm going to use my calculator to figure out the square root of 136 is 11.6619, and it's an irrational number that's going to keep going. So that's our side length for G. They asked us what is the perimeter for the triangle. So the answer to this problem is not going to be 11.6619. I have to take that, add 10, and add 6. So my answer is going to be 10 plus 6. Which gives us 16, plus the 11.6619, which is going to give us 11 and 16 is 27.6619, continuing. Because they want us to round to the nearest tenth, that means one decimal place. I look at the digit after, it's a 6, so I know I'm going to bump up my answer. My final answer here is going to be, 27.7, because I needed to round that 0.6 up to a 0.7. There's the perimeter for the green triangle. Now you're going to pause the video lesson and you're going to take some time to try to figure out what is the height, h, for the cone that's shown below, and you're going to estimate to the nearest hundredth. Welcome back. The important thing to see for a three-dimensional cone is that potentially we could have a two-dimensional right triangle standing up inside that cone if we use the height, the radius, and then the slanted height. That's what we have here. So if we want to find the height for a cone and we know the slanted height of 12 and the radius of 5, When I open this drawing, I understand the biggest side, C, the hypotenuse, is going to be the slanted height for a cone that makes A and B 5 and 12. The important thing to recognize, now I know C this time. I need to try to find out what B is, so I'm going to use the second version of this formula, C squared minus A squared equals B squared. We're going to replace the C with 12. We're going to replace the A with 5 because we're trying to solve for B, and those are the two values we knew. 12 squared gives us 144. 5 squared gives us 5. When you do 144 minus 25, it should have given you 119. And then your final step, you're going to take the square root from both sides. So when we do the square root of 119, we get 10.9087. So 10.9087 continuing for B, and remember we got that by square rooting both of our sides. And when I need to round that to the nearest hundredth, that's 10.90, but I have to look at the 8, so I'm going to round up to 10.91 is what the height, or side length B here in the Pythagorean theorem, is actually equal to.